So order of operations, always a thing. Yesterday we talked about how, maybe the day before, how you could just pop some stuff in the calculator and call it a day. But when you throw in variables, as you know, that's when things kind of get all messed up. So what we're going to do is work inside out. We'll start with this -2. It's going to get distributed. The good thing is we don't have to write every single property as we're doing this, but you should be aware of what property you're doing or applying. So generally, when you decide what you're going to do, you're using the property that you're going to do, you're going to apply. So when I say I'm going to distribute this -2, I don't then need to say using the distributive property, because I think I've kind of already addressed that. All right, so 4x plus 2 times 4, and then we're looking at minus 2x minus 4, close parentheses, equals 2x minus 4. The biggest question that I usually get is, will that negative sign come along for the ride when dealing with the distributive property? And the answer is yes. So this negative sign here, you just have to know it's not just the 2 going in, it's the negative also with it. All right, so it's a new operation. So that's how I get rid of mistakes, by the way. It's fun. Awesome. What'd you drop? Oh, it was you. I thought it's funny because you had the guilty look on your face, but you're the one who dropped it? Oh, all right, cool. That's awesome. So we now know that you can like literally blame him for anything and get away with it. So yeah, you're good. So, all right, so what's going to happen next? Inside the brackets, we could do what? Combine like terms, exactly. And so those like terms that we would want to combine would be the 4 and the -4?
Yeah.
Yes, cancels out, indeed. One's positive, one's negative. All right, now you can continue on the fly here, but I'm going to show all the intermediate steps, at least this one time around. Now, there is no change to the right-hand side of the equation, so if you want, you could just put the equal sign and leave the right-hand side blank. That's something you probably should know from middle school, but I can't guarantee that that's the case, so I'm just going to continue on and listen. All right, so then what's next? Just give me a word. Distribute, that works. I mean, distributing usually applies when you're dealing with multiple terms within a set of parentheses or, fencing. So whether it's parentheses, brackets, whatever. So technically, it's not the correct term, but it's the right idea, and that's good enough for me. And my rationale behind that is I haven't really talked about terms yet. So, how would you know? So, but really just multiplying. 2 times -2x would be -4x. So 4x minus 4x, 0. So now I'm going to incorporate the right-hand side. So 2x minus 4. Oh, spoiler. So what do I do now? Add 4 to both sides. We're looking at 4 equals 2x. Then what? Divide 2 both sides. And so then we get, as you said, x equals 2. 2 equals x, x equals 2. Equality is commutative. You can write it either way. So whichever way you want. But now, there's also a component when solving equations where you should check your work, plugging in your x value to the original equation to make sure it works as a valid solution, but I leave that up to you to do. It's not something I'm very often going to ask you to do. There's only really a couple of situations in the course where I'm going to say, and be sure to check your work, because sometimes you could end up getting a value for X and it still not end up working in the problem. So, but for now, it's going to be fine. All right, number two. Number two is kind of why we're here, because this fraction stuff. We like fractions. Mere child's play. We like fractions because we know how to get rid of fractions, so they're not really intimidating, right? When dealing with equations. All I have to do is what? Multiply by 8. Multiply both sides by a common denominator. All right, multiply both sides by a common denominator. All right. So since there's only one denominator here, there's no real thinking involved. I'm going to multiply both sides of my equation by 8. All right, on the left side, it's easy because the 8s are going to cancel. Now on the right-hand side, the 8's going to get distributed to each term. Poor quality error, so let me just fix that real quick. I'm going to move it up. I'm going to get back involved over here. So what do I get when I multiply 8 by 3n? 24n. Boom shakalaka. What do I get when I multiply 8 by negative 5/8? Exactamundo. Fractions aren't intimidating, fractional equations anyway aren't intimidating because they don't have to be fractional equations. We could change them. We can make them linear equations, right? So, next step. Add that 5. So 12 is equal to 24n. Final step.
Divide by 24.
Exactly, very good. And what is 12 over 24 equivalent to? 1/2. Oh, where'd my line go? That's weird. Oh, it just kind of left me. 1/2 equals n. We're not surprised by a fractional answer. Question?
Can you also do it, like, solve it algebraically, like, add 5/8 units on each side?
Yeah, sure. And in this case, it's perfectly fine because you get clean values right from the get-go. But one thing I will say is when we start making the problems a little bit more complicated, this technique is something that you're going to want to know. Right? So that strategy is a good strategy to use if you recognize it as, oh, it's not going to be too bad if I do it that way. But once you see more complicated cases, you'll kind of know when you see it. Let me try that new strategy. All right. So just, and that's the general rule of thumb for the course. Just always be open to the new strategies. Don't get locked in on any one that you might have seen before, because odds are the strategy that you're comfortable with, it'll work in most cases, but then there's going to be the handful of cases where it'll work, but it's going to be a nightmare. All right, it's the most roundabout approach to solving a problem. Whereas a new strategy or something suggested by a classmate or even me, or maybe something you see online that you hadn't thought of, maybe it's not something you're comfortable with, but if you give it a shot, it's like, oh, I never thought of that. It makes sense. I wouldn't use this all the time, but for this one situation, it makes perfect sense, you know? So, you know, an example of that might be something like number 3 for your technique, saying I'll just subtract the 2 from both sides and divide. But then when you get to a problem on the next page, I don't want to flip because I'll lose my video, but a problem on the next page, maybe one of the other, the technique that we just used would be more appropriate. You know, so you want to be malleable when you're using the different strategies, all right? So you don't want to just lock in on one, all right? So yeah, let's use your strategy for number 3. We want to subtract 2 from both sides. Five, 6x is equal to, and then we just need to subtract. Fortunately, our calculator is not intimidated by fractions either. So alpha y equals, that brings up the fraction shortcut key. Remember, alpha y equals, that's something, you know, we all kind of come to the party at our own times. And so over the last few days, more and more people have been flagging me down saying, hey, so where's that fraction shortcut key again? And you know, more and more people I'm kind of letting in on the secret, but you know, it really shouldn't be a secret. So alpha y equals, the first option brings up the fraction key. All right, 1/3. Hit the right arrow to get out of it, minus 2, hit enter. It puts it in simplest form for you. That's pretty awesome, right? I guess not. I mean, I thought it was awesome. You remember simplifying fractions, right? Some were easier to do than others, right? This does it. It doesn't matter how hard the problem is. It's going to do it instantaneously. That's pretty awesome, right? Yeah, okay. Well, at least 2 people now said yeah. Maybe on Monday I'll define the word awesome so that we all know. Maybe it's one of those antiquated terms that people don't know anymore. Like cool. You guys don't say cool anymore, right?
Cool.
Yeah, right? Oh, you do? Okay, so that's still it. Awesome, is that a thing?
Yeah.
Oh, okay. Wait, you know what awesome means? Oh, so you're just saying what I said was not awesome. Like when I said that was pretty awesome, you were just disagreeing by not saying yes. Oh, okay. Oh, okay. I just misread the room. No, I understand now. Okay. It was my fault. I don't know the definition of awesome anymore. I'll figure it all out. All right, so we're going to divide both sides by 5/6. Now, you could multiply both sides by 6/5 if you want, but again, the calculator understands fractions. Alpha y equals option 1, 5/6. Oh, not like that. Jeez Louise. Just made that up. I don't even know who Louise is. And you get a -2. All right. So, not too bad. So I won't say it's awesome. I'll just say it's not too bad. It's okay. All right, so you could apply that technique on the next one, or you could clear out the denominator using the technique from the do now. But what I'd like to do is let's jump to the next page and do something a little spicier. 7's a good looking problem there, right? All right, looks like we have 2 denominators to worry about here. But I can handle them separately from one another. Let's tackle that 7/3 first. The 7 I'm not worried about, it's the 3. How can I get rid of that 3? Multiply both sides by 3. All right, so that's going to destroy the 3 on the left-hand side. It's going to annihilate it. All right, now I could do a couple of things. You might consider multiplying through with the 7 using the distributive property. Another thing you might consider doing is dividing by the 7, but if you divide everything by 7, then you're going to create a denominator of 7. Like on the right-hand side, it's going to be 60/7. We're trying to get rid of the denominator, so I think that's going to be counterproductive. So I'm going to opt to distribute the 7. The good thing about solving equations is if you're following a property of equality or a property of numbers, no matter what property you're doing or applying, you're not doing anything wrong as long as you're applying those properties correctly, right? So if you divided by 7 first, where I multiplied by 3 first, all right, you're not wrong. Right? It may take one of us longer to do the problem, but neither of us are wrong. So your brain might take you in a different direction. That's perfectly fine. Right? So we're looking at 7x plus, now I got to multiply 7 by 9 over 28. So 7 times 9 over 28. This is your bailout for forgetting how to multiply a whole number by fractions. Right? Because when you multiply a whole number by a fraction, the whole number only gets multiplied by the top of the fraction, right? So if I were to actually multiply this together, it would be 63 over 28, and then I'd have to reduce it. Calculator's going to do that all in one shot. Look at that. I heard a wow. I'll take it. Wows are good. Now what? Multiply by 4. The whole shebiggity bang. All right, so 4 times 7x, 28x, 4 times 9 fourths,
9.
that's 9. Yeah, you could cancel the 4s, exactly. 60 times 4?
Oh, it's 140.
240. Subtract the 9. You get 231. Try not to sneeze. Try not to sneeze. Okay, well, anyway, divide by 28. Eight and a quarter. So I got a decimal value. I'm going to math frac that. Math enter, enter. 33 over 4. All right, so sometimes you're going to get some greasy looking numbers, and that's okay. All right, so